Welcome back, Algebra fans. We are on lesson 8.3, graphing f of x equals ax squared plus bx plus c. So our central question is, how do you graph f of x equals ax squared plus bx plus c? Just so you're aware, this form right here where we have either a y equals or an f of x equals, with our a, b, and our c here, this is called standard form. All right, standard form. There are at least three total forms for quadratic equations. We're not going to get into all of them. This is the most common, and I think it's the most important. So we're going to focus on this one form, but I want you aware that there are other ones out there. So first thing we want to do is just remind ourselves that, hey, we already know, I should say chapter 8, we already know some stuff about quadratics in chapter 8. We already know about determining if a quadratic opens upward or downward. So let's take a look at our first three problems here. The first one is 2x squared plus y equals 7. In order to know whether it opens up or down, we have to move our x to the other side. So we have a positive 2x squared, that means we have to subtract 2x squared. So we have y equals negative 2x squared plus 7. Remember, this is how we want to write polynomials from the largest degree to the smallest degree. Now we can look at it and say, well, hey, our a is a negative 2. So if it's a positive, we know it's a smiley face because positive people are happy. And if it's a negative, it's a frowny face. And I know many of us are having more days that are like this than like this. But we have a negative 2 here. So that means that it opens downward. And then the other thing we need to find is the y-intercept. So remember, the opens upward or downward has to do with our a value. The y-intercept is always going to be 0, and then whatever our c value is. Whatever our c value is. This is when we're looking at f of x equals ax squared plus c. Well, we are adding 7. So this should be a 0, 7 for our y-intercept. All right, let's take a look at our next one right here in the middle. We have a negative x squared plus y equals 8. Again, we need to have y by itself in order to know what our a is. So I need to add x squared to both sides. So we get y equals x squared. What kind of an 8 is this? Positive or negative? Positive 8, so plus 8. So our a value is a ninja. He's right there. I just didn't write him in, but it's a 1. Now, is it a positive smiley face or a negative frowny face? Should be positive, right? Because I don't have negative written there. So this one opens upward. And then we're looking for our y-intercept. Y-intercepts are always 0, some number. Well, what are we adding? 8. So 0, 8 is our y-intercept. And then we have 7 minus x squared equals y. I'm going to rewrite that so my y is on the left. He's already by himself, which is great. And then I want to make sure that I'm writing this with the largest degree first. Well, which one has the largest degree? 7 or x squared? Which one has an exponent? Yeah, x squared. So I need to write x squared first. What kind of an x squared is this, though? A negative. So make sure you keep that subtraction sign with the x squared. And then what kind of a 7 is this? A positive. So this is really y equals negative x squared plus 7. I see a lot of students write this as x squared minus 7, but you have to be careful about which one has negative and which one doesn't, right? So be very careful and aware of that. So our a value, this is a negative what x squared? Negative 1. Hey, it's a negative. That means it opens downward. And then we want to find our y-intercept. Well, it's going to be 0, 7 in this case. So just reminding ourselves that we already know how to do that. We know how to do that. So let's take a look at some of the new stuff with 8.3. We know how to identify the vertex of a function. We know the vertex is either the lowest point or the highest point, right? It's going to be either the minimum or the maximum. So when we look at our first graph here, we have a point right here. That is the lowest it goes. So this one has a vertex that is a minimum. And when we read the graph, we would say it is at an x of -3 and a y of -5. That's that point right there, right? So we also need the axis of symmetry. I'm going to grab some different colors. Let's hope my orange doesn't break again. So the axis of symmetry is where it goes from decreasing to increasing as we read from left to right, right? It's where it switches from one to the other. It also happens where the vertex is. So we can see that if I were to fold my paper in half, that this side would perfectly line up with that side. So my axis of symmetry is right here. Now, what kind of line is that? Vertical or horizontal? It's a vertical line, which means if it's a vertical, it touches which axis? The y-axis or the x-axis? Yeah, it touches the x-axis, so this will be an x equals. Well, where does it touch the x-axis? It touches at x equals -3. Now, here's the cool thing. The vertex's x-coordinate is the same as the axis of symmetry. Isn't that great? So our axis of symmetry is at x equals -3, and our vertex is at -3, -5. I want you to try the next two, all right? I want you to try the next two. Find their axis of symmetry, find their vertex. So pause the video, try the next two. All right, for our next one, number 2 here, you can see our axis of symmetry is our symmetry is at x equals -2. And then you can see our vertex, and it is a maximum, right? Cannot go any higher, is at -2, 6. And hey, look at that, -2, -2. And then our last one here, our axis of symmetry is at x equals 3. And then our vertex is at 3, -3. And again, this one is a minimum, right? It's a minimum. That's as low as it goes. As low as it goes. All right, let's take a look at page 2. I'm going to turn this guy over. There we go. So, we know some things already about quadratics, especially in regards to f of x equals ax squared plus bx plus c. Right? We know some things. I'm going to sketch one for when a is greater than 0, right? When a is greater than 0. So I'm going to sketch a quadratic that looks something like this, right? My a is greater than 0. We know that the graph opens upward when a is greater than 0. We know that the graph opens downward when a is less than 0, right? So when it's a negative. We know that an absolute value of a that is greater than 1 is skinnier, right? And that an absolute value of a that is less than 1 is fatter or wider, however you like to say that. We also know that the y-intercept is c. Another way of saying that would be that the y-intercept is 0, c, right? We know that. So what's new is that the x-coordinate of the vertex is x equals -b divided by 2a, right? -b divided by 2a. This is also the axis of symmetry, all right? The axis of symmetry. is x equals negative b divided by 2a. I don't have a preference as to whether you put the negative with the b or if you just leave it out front, whichever you prefer. It means the same thing, right? So right here is my vertex, right? We know it's going to be some coordinate point xy. Right here is my y-intercept, so that's going to be the point 0, c. It's going to be the point 0, c, whatever c is. And then I'm going to do a nice yellow for my axis of symmetry. So it's something like that. That's my axis of symmetry. And what's really important about that one is that the line is determined by x equals negative b divided by 2a. So that's why this standard form of a quadratic is really, really handy, because we don't even have to graph it in order to find the axis of symmetry, which is pretty cool. So let's take a look at some graphs and see if we can identify the vertex as a minimum or maximum. So for our first one right here, we have a graph that looks something like that, right? So it's a downward opening graph. That means that this has a maximum. Another way of thinking about it is it's the highest point. It's the highest point. If you're thinking about when would I use this, why do I care? Anytime you throw something up in the air, it has a maximum height. It has a height that it goes to and then it comes back down, right? Thanks to gravity. So anytime you throw something in the air, this parabola, this arc, this quadratic is similar to whatever gets thrown, the ball, the coin, whatever it is. So we use this a lot in science because of that. If you have an upward opening graph, then you have a minimum for your vertex. Another way of thinking about this is the lowest point, right? It's the lowest point that the graph will go. Scenarios that are like this are like skateboard ramps, right? Those are some that have scenarios that look like this. I'm sure we could think of more if we really wanted to. So we're going to do these top two together. For this one, it is downward opening, which means if it's downward, then it has a, there it is, maximum. It has a maximum. So we can see our vertex right here very clearly. That is our vertex, and when we read that point, it is at 1, 5. It is at 1, 5. Now the question is, what is the maximum? What's the highest it goes? Is the highest it goes 1, or is the highest it goes 5? The highest it goes is 5, right? That's as high as it goes. So the maximum always has to do with what the y value is, right? The maximum or minimum has to do with the y value. The y value of the vertex. So let's take a look at our next one here. Let's take a look at our next one. Ooh, maybe a pendulum is swinging. Maybe that's what's going on here. We can clearly see our vertex. Again, it's a nice point, easy to read. We know it's at -2, -5. Then we need to determine if it's a high point or a low point. Well, this is an upward opening. So that means if it's upward, it is a minimum. And our minimum is that -2 or is that -5? What's the lowest the graph goes? -5. So our minimum is at -5. All right, I want you to pause the video and try the next two. All right, pause the video, try the next two. All right, for number 3 here, our vertex is at -2, 5. It is a maximum at 5. For number 4 here, our vertex is at 3, -1. It is a minimum at -1. So not too hard to read the graph, right? Pretty easy. All right, let's take a look at page 3 next. Page 3 next. We want to find the axis of symmetry using the formula. Finding the axis of symmetry using the formula. So remember, we have something like f of x equals ax squared plus bx plus c. This could be y equals ax squared plus bx plus c. It doesn't matter if it's f of x or y, right? One's function notation, one is y. It's fine either way. But this is the standard form for quadratics, or the quadratic standard form. And we know that our axis of symmetry is x equals negative b divided by 2a. Negative b divided by 2a. So let's just say for our first one here, and I'm going to give myself a nice little line between them so I don't go over, because I do that sometimes, I know. Let's say we have an a. What's our a value? What number is next to our x squared here? Hint, hint. He's a ninja. Yeah, positive 1. And then we have our b. Well, the next one is plus what x? 3. So our b is 3. And our last number is 4 for our c. So to find the axis of symmetry, I need to use this formula. So I'm just going to write it down. X equals negative b divided by 2a. I don't need to use c at all, right? So I'm going to plug in 3 and 1 where I need them. So x equals negative 3 divided by 2 times 4. Oh, 2 times 1. Excuse me, 2 times 1. Because this is a, not c. Silliness fresh. So we have x equals negative 3. 2 times 1 is 2. You could also write that as negative 1.5. So on our graph, at negative 1.5, that is where our vertex would be and our line of symmetry, right? That would be the line. So x equals negative 1.5 is our axis of symmetry. All right, I want you to try this next one. Find your a value, your b value, and your c value. Pause the video, try the next one. All right, so we are plugging in for our axis of symmetry. A is 2, B is 1, and C is 3. So we get negative 1 divided by 2 times 2 for our x. So that's negative 1/4, which you could write as negative 0.25, because I know some of you really, really like decimals. So this one would be x equals negative 0.25. I always prefer the fraction, but if you really like the decimal, that's fine in this case. Now we know how to find the axis of symmetry, and we know that the axis of symmetry is the x-coordinate for the vertex. Let's actually try finding the vertex without graphing. All right, let's try finding the vertex without having a graph done for us. So the first step, we need to find the axis of symmetry. That's the very first step, is find the axis of symmetry using the formula. Because it's the x value of the vertex. Remember, it's an x, y, right? So we're going to determine what a is, what b is, and what c is for our first equation here, which should say y equals, but the y just didn't print for me, I guess. Our a is 2, our b is 8, and our c is 1. 2, 8, and 1. So when we plug that into x equals negative b divided by 2a, we have x equals negative 8 divided by 2 times 2. Well, 2 times 2 is 4, so that's x equals negative 8 divided by 4. That means x equals negative 2 is our axis of symmetry. That is our axis of symmetry. So step 2 says to substitute your x value into the equation and solve for y. So that means I am doing y equals 2x squared plus 8x plus 1. I'm putting in negative 2 everywhere I see an x. So y equals 2, parentheses, negative 2 squared, plus 8, parentheses, negative 2, plus 1. Take it one step at a time. Remember your PEMDAS. So So y equals, exponents go first. So that'd be 2, negative 2 squared. Well, negative 2 times negative 2 is really 4. Plus 8 times negative 2 plus 1. Now we have to do parentheses. So y equals 2 times 4 is 8. Plus 8 times negative 2 is negative 16 plus 1. Now I can just add them together. Well, 8 plus negative 16 is negative 8. Negative 8 plus 1 is negative 7. Negative 7. So then now that I know my axis of symmetry, and I know this would actually be the min or the max. I don't know which yet. I would have to determine if it opens up or down, right? Now I can plug in both of those to the vertex as x, y. Well, my x value is negative 2, and my y value is negative 7. So my vertex is at negative 2, negative 7. And we could determine if this opens upward and is a minimum, or if it opens downward and it is a maximum. So we could do that if we wanted to. All right, let's try putting this all together, okay? So we're going to take a look at the next page. We have an equation right here. We are going to find, and I'm going to slide the page for just a second so you can see. We're going to determine if it opens upward or downward, what the y-intercept is. I'm going to show you what this mirror point is and how we plot it, because the vertex, the y-intercept, and the mirror point allow us to graph a quadratic equation. We need to have 3 points to graph it. We're going to find the axis of symmetry. We're going to find if it's a minimum or maximum value, and then we're going to find the domain and range. We're going to find everything we can possibly find about this equation, right? It should be fun. So, the very first thing we want to do is determine what our A value, our B value, and our C value is. Because once we have those picked out, we can do everything else, right? So our A value is this 3. Our B value is negative 6. Make sure you include that minus sign with your 6. And then C is 5. I'm just going to start with the first question on the bottom, which says, does it open upward or downward? Well, if it's a positive, then it opens upward for A. If it's a negative, then it opens downward. So which do we have, a positive or negative? Yeah, we've got positive, so we know it opens upward. So circle upward at the bottom of the page there, or write it down somewhere. The next thing we want is the y-intercept. The next thing we want is the y-intercept. Well, we know the y-intercept has to do with C. And remember, the y-intercept is always 0, C. So in this case, the y-intercept, if C is 5, would be 0, 5. That is our y-intercept. So down here at the bottom, where it says y-intercept, write down 0, 5. All right, it has to be a point. Don't just tell me 5. The y-intercept is always a point. All right, the next thing we want to do is slide up, and we are going to find the axis of symmetry. All right, so that was 1, that was 2. Next, we are on to the axis of symmetry, which is x equals negative b divided by 2a. Our b value we said was negative 6, so x equals negative 6. I like to plug it in with parentheses. It just helps my brain. And then our a value is 3, so 2 times 3. Well, negative 6 is really a positive, and then 2 times 3 is really 6. Hey, 6 divided by 6 is 1. So we know that our axis of symmetry is at x equals 1. So when I look at my graph here, I haven't done a scale yet. I'm going to count by 2, so 2, 4, 6, negative 2, negative 4, negative 6. So really each block is worth 1. I just don't want to have too many numbers on here. It gets really crowded that way. I know that this is my x and this is my y. So I'm going to find where x is 1, which is right here. And I'm going to draw my axis of symmetry. So there it is. There's my axis of symmetry. The next thing I want is to find my vertex. All right, the vertex is the next thing I want. Oh, and I know my y-intercept. Let's mark that on here too, because it's 0, 5. That's our y-intercept. So we already determined that. All right, to find the vertex, I need to take my x value and plug it back into the equation. So I'm going to do f of 1 equals, actually let's do f of x equals 3x squared minus 6x plus 5. I'm just going to copy the equation down, and then I'm plugging in 1 everywhere I see an x. So f of 1 equals 3, 1 squared, minus 6 times 1 plus 5, right? Everywhere I saw an x, I plugged in 1. I'm going to slide this so it's easier to see, and I don't run off the page. So start with your exponents first. F of 1 equals 3 times 1 squared is 1, minus 6 times 1 plus 5. Remember your PEMDAS. F of 1 equals 3 times 1 is 3, minus 6 times 1 is 6, plus 5. Well, now we have 3 minus 6, which is negative 3. Negative 3 plus 5 is a positive 2. So another way of saying that would be that y equals 2. If you really don't like your f of x, you can always change this into a y. Remember, this just helps us because it gives us the point. All right, that's why I like to use it, because this is the point for the vertex. It's the point for the vertex. So I don't care which way you write it, but the vertex is at the point 1, 2. So I go to 1 and 2 on my graph. That is my vertex right there. That is my vertex. Now that we know the vertex, we can, and we know it opens upward, we can say if this is a minimum or a maximum. Well, if it opens upward, that means this is the lowest point. So down here, let's fill in some information. Our vertex is at 1, 2. We know that because it opens upward, that this is a minimum. So I'm just going to cross out my maximum because it doesn't apply. And the minimum value is at where y is 2. That's our minimum. The axis of symmetry we found, it's x equals 1. The domain, hey, remember quadratics have the same domain every single time. It's all real numbers. All right, all real numbers. If you like doing my kind of funky R for that, that's fine. The range. If it's a minimum, that means y has to be something compared to 2. It's either going to be greater than equal to it or less than equal to it. If it's a minimum, that means that y is always greater than or equal to 2. So the very, very last thing on here is this y-intercept mirror point. Let's talk about that for a second. The y-intercept mirror point. I have my y-intercept right here, and this axis of symmetry acts like a mirror, right? So if I know my y-intercept, then I can mirror it, I can reflect it across where my pencil is. It is 1 block away from my axis of symmetry. That means my mirror point is going to be right here. Now that I have 3 points, I can sketch what this quadratic looks like. Right? I can sketch what this quadratic looks like. And it's not perfect, but it's a pretty good sketch. Make sure that you have arrows at the end, that it goes from edge to edge, right? This one's a pretty narrow quadratic. I really don't like how that turned out. It needs to be a little more, there we go, a little more narrow. And make sure that it's not pointed at the bottom. It should be rounded, right? It should be rounded at the vertex, not pointed, rounded. So then we have to ask ourselves, what is this point? We know that our y-intercept is at 0, 5. We reflected it, and our new point is at 2, 5. And our vertex, we already said, was 1, 2. So down here, the last thing I'm going to write in is what my y-intercept mirror point is, and that we said was 2, 5. You will have to graph these. Not take a Desmos of it. You will actually have to graph these as a part of this unit. So practice, all right? I want you to turn to the next page, page 5, and try the next one on your own. Try the next one on your own. So I'll post it for you to view. Try finding everything you need to find on this one. Pause the video, try it. All right, this one says h of x. This one says h of x. It really doesn't make a difference. You can still call it y, all right? So we have really y equals 2x squared plus 4x plus 1. Our a is 2, our b is 4, and our c is 1. That means that we have an opening upward, right? And our y-intercept is at 1. Our y-intercept is at 1. When I find my axis of symmetry, you should find x equals -1. So I have it drawn on there, right there. Then I plug in -1 everywhere I see an x up here, and that gets me a y value of -1. So my vertex is at -1, -1. I know my y-intercept, then I can mirror it. So the y-intercept is at -2, +1. So that means we've got an upward 0, 1, -2, 1. Our axis of symmetry was at -1. Remember, domain for every quadratic's all real numbers. Again, you can use my funky R if you like that. The vertex was at -1, -1. Because it opens upward, that means it's a minimum, so just ignore your maximum. And y must be greater than or equal to -1. All right, try the next one. Try the next one. So flip it over, try the next one. It looks something like this. X squared minus 8x plus 7. Try it out, see what you get. So our a value for this one, our a value is 1, our b value is -8, and our c value is 7. When I plug that in for my axis of symmetry, I get x equals 4. Because a is positive, we know it opens upward yet again. We have our y-intercept. It is at 7. You probably had to use a scale of 2 for every block on this one in order to get to work out right when you went to graph. So here is our y-intercept, 0, 7. Once I find my axis of symmetry, I can plug it in so you get a y value of -9. Your vertex is at 4, -9. Because it opens upward, that is another minimum. We reflect our y-intercept across our axis of symmetry. So we end up with a y-intercept near point of 8, 7. Domain for all quadratics is all real numbers. And then the range would be y is greater than or equal to -9. Because if it's a minimum, it's going to be greater than or equal to. The maximums only have less than or equal to, right? I know these are a lot of work, but they're very important. We're going to keep doing them for the rest of this year, and you're going to see them all over the place in Algebra 2. So it's really, really important. All right. The next one is 5x squared minus 10x minus 2. So try graphing this one. Pause the video, take a few minutes, try graphing it. All right, first thing, it has a -5 for your a value, -5 for your a value. That means it opens downward. And our c value is -2. So the y-intercept is at 0, -2. We plug in our -10 to find, for b, to find our axis of symmetry. And we plug in -5. Well, -10 is really +10. 2 times -5 is really -10. So our axis of symmetry is at x equals -1. X equals -1. I used a scale of 2 to graph this. You could easily do it with a scale of 1 and be fine. Our y-intercept is right here at 0, -2. We plug in -1 everywhere we see an x, and you should get a y value of 3. So your vertex is at -1, 3. Now that we have our axis of symmetry and our vertex, we can reflect our y-intercept across that axis of symmetry. So you get -2, -2. It is a maximum. It is a maximum value. So that means that y has to be less than or equal to 3 for your range. All right? It's a maximum, so you can just ignore that minimum there. And domain is always all real numbers. I know that this is challenging, so please, 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 please email me with questions, all right? Email me with questions.